Okay, so in this first example, you are going to look at an example where you have two sets of equations where the coefficients are the same but opposite. So when you have this, all you're going to do is add. So if you open it up and look at the examples, we have 3x plus 4y equals 2 and 4x minus 4y equals 12. Now these are already written in standard form, which is perfect for elimination. So if you look closely, our terms with our y have the same coefficient of 4, but they are opposites. We have plus 4 and we have minus 4. This is perfect. So what we're actually going to do is we are going to add straight down with these two equations. Now when we do this, we need to make sure that our terms are aligned. We have our x's together, we have our y's on top of each other, and we have our constants together. Okay, so this is the format you want to start off in. So what you can literally just do is add straight down. So 3x plus 4x is 7x. 4y plus negative 4y is 0y. You actually don't even need to write that 0y. And all this equals 2 plus 12, which is 14. So really, I have 7x equals 14. I have eliminated my y's, hence the elimination method. So all I have to do from here is divide both sides by 7 to solve for x. So x equals 2. But I'm not done, because I also need to find out what my y value is. So what I can do is I can take this x equals 2 and substitute 2 in for x for either one of these equations. I'm just going to go ahead and use the top equation. So right now what I'm doing is I'm finding y. So I'm going to take this top equation, 3x plus 4y equals 2, and substitute substitute 2 in for x. So I have 3 times 2 plus 4y equals 2. 3 times 2 is 6, so I have 6 plus 4y equals 2. And again, my goal is to solve for y, so I'm going to subtract 6 from both sides. So I have 4y equals negative 4. Divide both sides by 4. So y equals negative 1. And I can write my whole answer as a coordinate where x is 2 and y is negative 1. So there's my solution for this top example system of equations. All right, moving on to this example, I have the similar setup where both of them are written in standard form. And looking, I see that here my x values are the same but opposite coefficients. So they both have a 3, but I have a positive 3 and I have a negative 3. So again, in this example, I'm going to add the two equations together. So 3x plus negative 3x is 0x. 2y plus negative 5y is negative 3y. And negative 19 plus positive 25 is, I'm doing this before I have my coffee, so excuse me, is positive 6. Okay, so really all I have here is negative 3y equals 6. So to solve for y, I divide both sides by negative 3. So y equals negative 2. Okay, so now I have my y value, and what I need to do now is I need to find x. So again, you can use either one of these equations. Since I used the top one for the first example, I'll go ahead and show you how to use the bottom example for this one. So I have negative 3x minus 5y equals 25. So I don't know what x is, so I can rewrite that term, but I know that my y is negative 2. And all this equals 25. So I have negative 3x minus 5 times negative 2 is negative 10 equals 25. Really, minusing a negative is the same thing as adding a positive, so this becomes 3x plus 10 equals 25. So to solve for x, I'm going to subtract 10 from both sides. Negative 3x equals 15. Divide by negative 3. And once you become more familiar with this, I'm not expecting you to write out like negative 5 times negative 2 is minus negative 10, all that good stuff. So really this becomes x equals negative 5. And I can write my solution as negative 5 comma negative 2. So if I were to graph these two solutions, these two lines would intersect at the coordinate negative 5, negative 2. Okay, so that's how you're going to solve them if you have the same but opposite coefficients for either your x or your y.